All right. Hey, hey, folks. Welcome to another lecture in the Spark series. This is lecture 7. Before specifying the agenda for today's lecture, let me ask you a question. See, keeping about the fact whether you are a professional or a intermediate level or at beginner with Python, how often do you define your own functions when you are working with Python? More specifically, why do we need to define our own functions in Python? I mean, along with that, do we have the flexibility of defining our own functions in Spark when you are working with pyspark? So the answer for the second part of the question, do we have the flexibility? Yes, we do have the flexibility of defining our own functions in pyspark. So for that we need UDF, which is abbreviated as user defined functions. We need to import that from the pyspark.sql.libraries. I mean pyspark.sql.functions libraries. So I think you are aware of today's agenda with that saying. So let me specify my agenda for today's lecture, which is discussing about UDF, which follows as reading the documentation as usual and specifying or answering the why we need UDF, and followed by discussing about the similarities and dissimilarities between a function, user-defined function in Python and user-defined function in PySpark, and also looking at a user use case. Let's end the session by looking at a use case. So with that saying, let's begin our lecture. But before that, let me switch into my Databricks workspace. So here we are. Let's begin by okay. Let as said, our objective one is looking at the documentation. So as I said, we need to import if you need to work with user-defined functions in PySpark. We need to import some libraries which are from pyspark.sql.functions import UDF, which is abbreviated as user defined functions. So let's use a help function on UDF. I mean, help function use the documentation. See, the very use of documentation is to get a better understanding. Okay, let's look into the documentation. Help on the function UDF in module pyspark.sql.functions. UDF, which takes inputs and returns a specific output. Let's look into the parameters. F, which is function, Python function if use it as a standalone function. Return type is class, which is pyspark.sql.types.data type or string. Well, I don't think you will be you will have a good understanding about UDF with this documentation. I don't think with this documentation you could have a good understanding. I will give a detailed explanation. Okay, let's see the example. So okay, here it is UDF. So if you need to define a function in PySpark using UDF, we need to specify that initially using @UDF and def as similar to a Python def, and a username and the inputs and a return part with some operations. So let's look how they created. Don't hesitate to look into that example. Let's create our own example. So for that, let me create a data frame, a simple data frame. Okay, data. So yes, here is our data. Let's create a df data frame using spark dot create data frame using data and schema. Sorry. Yeah, here is our data with four fields or four columns, with first column as serial number which is long, second column subject which is string, and marks which are long, category again a string. So okay, let's create a simple objective for this data. The objective is create a new column which is titled as subject code, which takes, I mean, the items for that column are first three letters of subject, respective subject. So for that we need to create a UDF, which is user defined function. I'm using the same example. If you have watched my previous lecture, which is on with column function, I just use the same, I mean, same objective here. I'm just repeating the same objective, but with clear explanation, I suppose. So if you need to create a user defined function, we need to specify a simple thing, that is at the rate UDF, and then define our function, which is update. Let's treat the name as object, which takes string as input and returns sliced part of that string, which is 0 to 3, I suppose, and use that function. So df dot with column, and give the column name as subject code, and it takes, use the function that we have created, update, which takes an input which is subject, and let's show our results. Okay, I just made an error. It's a slicing using parenthesis, closed parenthesis. Yeah, here is our, I mean, we just met our objective. But let me clear one thing. When you are defining a function, we just treated the input as a string, a particular string, and the written part is the sliced part of that string. But when you are using that function, when using that function to result our specific objective, we just passed on a column name which is subject from the df that we just created. We just pass the name of the column as an input. So what internally happens is it takes a whole list of items from the column, and performs the operation defined in the function, and each respective output is, I mean, mapped, and the result, whole result will be given as a part of df. So the very first thing that we need to remember is to specify it as a user defined function with this syntax, and when you are using that function, we need to specify the column name. So this is what actually here in the documentation, I suppose. And okay, let's jump into the step 2, which is defining why we need a user defined function, whether it is pyspark or, I mean, python. Why we need user defined functions? So the very reason, the very first and the very best reason that I could think of for that why is customization. See, yes, we have many libraries and many functions when we are working with Python, but all those are limited to specific use. Meaning we can't meet our whole objective when with using that limited, I mean, defined I mean, inbuilt functions. With that inbuilt functions, not all the objectives will be met. So for that reason, we need customized. I mean, we need customized functions which results customized outputs. So the very best and very first reason that I could think of is customization. We need custom results, so that for that we need custom functions, and flexibility. Flexibility could be another reason, and I mean, we can use many operations on the data types, and I mean, we can even convert a part of string to an integer if it is defined with if the string is defined with numbers. Let's not bother about that, which is part of, I mean, it's an example for flexibility. And also you can use that as many times as you need, which is termed as reusability. You can define it one time and you can use as many times as you need. So I mean, I could think of these three reasons. There could be many reasons, but these are very much why, very much answers our why we need user defined functions. So I just think we met our step 2, and let's jump into the step 3, which is use case or test case. Okay, for that, uh, let me load a file first. File location. Let me copy the file location, which is, yeah, here it is. Let's copy the path. Okay, this is actually a CSV file. So let's load our file. df2 spark dot read dot csv with file location, and let's keep info schema as true to info schema from the data itself, and also header as true, and let's also print our data, I mean data frame. Yeah, here is our data frame. Let's I mean, you can see that we have several fields, but the specific field, which is C7, the name of the field, which is string, is actually a error, I think, from the user. So let's select only the specific columns. If for that, df2 dot, I'm not aware whether you are aware or not with the function column, which actually results a list of strings. Columns, actually a list of column names, which are actually the strings. Each string is the name of the column name. So you can even use a slice on this, as it is a list. I mean, if you can use slice, then it just ignores the last column name. So with this slicing columns, we just select df2 equals to df2 dot select the specific columns, I mean df2 dot columns of 0 to -1. I mean, we just wanted to ignore the last column, which is C7. It's just a mess, I suppose. So yeah, here is our df2, which is just a columns, I mean with the specified columns. Let's print our df2. Yeah, here is our df2. So let's not bother about what is this df and what are the specific fields. That's not the entire that's not our concern here. Our major concern is which is sum of monthly earnings and sum of the highest yearly earnings. See, if you can look into it, it's actually should be an integer, but when you are, I mean, when the file is created, it's treated as a string with some errors. I mean, a question mark in prior to the number. So let's convert this. Our objective is, let's define our objective here. Convert the string part of yearly and monthly columns to integer part using our own defined function. So let's create a function which converts, yeah, so let's create a function which converts this integer, sorry, it's string into an integer part. So let's define our own function for that. At rate UDF, we need to specify this every time we define our function, and let's name it as convert you can name it as you need. So it's take input as a string, and so let's break into our whole problem into steps. So first we need to get rid of this question mark prior to the string, and also we need to get rid of this commas and then convert that into a string, I mean integer. So let's create a variable which stores the sliced part of the string, which is, I mean, you can see that every we need to get rid of this first two places of every string to get rid of that question mark. So let's get rid of that. So sliced part, so this get rid of that question mark, and let split, I mean, let me specify the output for this step. Okay, if input is, let's take the first item. If input is the first item, which is this, then the output for this S1 is 10, 15 and 100. This is the output. So for this, let's split at this commas. So let's store that in another variable, that S1 dot split at the commas. So the output for this S2 will be, I mean, a list of items, a list of strings specifically, which are 10, 15, and the third will be 100. I mean, if again, I mean, using a S2 on this, I mean, split on this string will result this result. So let's combine this string using a join function. So S3 will be, I mean, join without any delimiter dot join our S2. So the output of S3 will be again a string without any delimiter. This is our output. So let's return the integer part, return int of S3. Okay, this converts the string, which is this, into a string. So the return part results integer of, it's just return which is an integer. So this completes our function. So let's use that function on our df2 dot, let's store the data as df2 again, df2 dot with column, sorry. Again, if you are not aware of with column, then you can watch my previous video on with column. So it takes two inputs. First input will be name of new column, which is, let's say, monthly, and use the function convert, and the input will be a string, I mean, name of the column on which we need to use the function. So with that, let's print our df2. Let's not store df2 but df3. Okay, we just ran into an error. So let's debug this. Column function parameter cannot be resolved. Okay. The error here is, we just thought this sum of the monthly earnings is only the part, I mean, is the only name of the column, but here it says that it has, I mean, space before and after the name as well. So our actual name of the column is this with the space before and after the name. So let's run that. So yeah, here we are with monthly as a new column, and which is integer, I suppose. Let's print our schema. Yes, monthly is a string, and we just converted our monthly earnings. Oh, sorry, it should not be a string. Okay, I suppose converting a string into an it just return the integer but doesn't actually convert a string into an integer. So let's use cast function. I mean df3 equals to df3 dot with column. Again, if you're not aware of cast function, it's just convert one data type to another data type. So let's use that on monthly. Let's store that on monthly as well. So df3 dot monthly, this df3 dot monthly which subjects the monthly column. So for on that we use cast and specify the type of data type that we need to convert into, and we just need to convert that monthly column into integer part. So how we read this, it means cast that df3 dot monthly column into an integer. So let's print that df3. Yeah, here it is with the same results, but let's look into our schema. Yeah, we just converted that integer, sorry, string into an integer. So I suppose printing an int function doesn't really convert that data type, so we just have to use cast function, which is an inbuilt function. Again, if you are willing, we can define your own function instead of cast function, which takes in input and returns integer, which is specifically the same here. But yeah, let's not bother about that. We just meet our objective, which is converting this string type into an integer part. So yeah, well, with that we just met our step 3. I mean our whole agenda for today's lecture. So let's rewind the whole thing, which is step 1, looking at the documentation. So the major takeaways from the documentation are these. I mean, if you are specifying a user defined function, then you need to specify this syntax, which is UDF. And again, I think we can even specify the return type. I mean UDF of return type. You can even define our return type, which is whether integer type or string type. But for that, specifying type of function that we need to return, we think from pyspark.sql.types, we need to import string type and integer type. So after importing these types from the sql.types library, and we can specify our return type. And oh sorry, and we can specify our return type, which is string type. So whether you define your whether you specify the return type or not, but UDF at that UDF you should specify. And again, the second takeaway is when you are defining function, the inputs can be any data type, whether it is string or integer, and the number of inputs depends on user defined, user specific. But when you are using the same function, the input should be the name of the column on which you want to use that function. Here in this case, subject is the name of the column of data from df on which we used our function. And yes, using with column, it creates a new column. And the second step is, objective is why we need user defined function. Again, there could be many reasons, but the specific reasons that I could think of is very first and very best reason that I could think of is customization. We need customized outputs. For that, we need customized functions, and that is why we define our own functions. There are many functions inbuilt, many libraries that we can import, but not all of them can combinedly solve all the problems that we have. So for that we need user defined functions and reusability is also a, I mean, best reason why use UDFs and test case. And the major objective of test case is we just read a DF, I mean a CSV file into a DF, which in which we our major objective is convert this string, which should be an integer part, into an integer part, actual integer part. That is our objective. So for that we defined our where is that function? We just defined our own function with the knowledge that we have just gained, and use that function on the column which is sum of highest monthly earnings, and converted that column into an integer part using cast function. So yeah, with that we just I mean completed our objective. And so yeah, that is for today's lecture, and let's meet in another lecture.